Good morning, everyone. Regression concepts. Introduction. The term regression is used to indicate the estimation or prediction of the average value of one variable for a specified value of another variable. Regression analysis is a very widely used statistical tool to establish a relationship model between two variables. Regression analysis is a statistical process for estimating the relationships between the dependent variables or criterion variables or response variables, and one or more independent variables or predictor variables. Regression describes how an independent variable is numerically related to the dependent variable. Regression can be used for prediction, estimation, and hypothesis testing, and modeling causal relationships. When regression is chosen, a regression problem is when the output variable is a real or continuous value, such as salary or weight. Many different models can be used. The simplest is linear regression. It tries to fit data with the best hyperplane which goes through the points. Mathematically, a linear relationship represents a straight line when plotted as a graph. A nonlinear relationship where the exponent of any variable is not equal to 1 creates a curve. Types of regression. Analysis techniques. Linear regression, logistic regression, ridge regression, lasso regression, polynomial regression, Bayesian linear regression. Advantages and limitations. Fast and easy to model and is particularly useful when the relationship to be modeled is not extremely complex and if you don't have a lot of data. Very intuitive to understand and interpret. Linear regression is very sensitive to outliers. Linear regression. Linear regression is a very simple method but has proven to be very useful for a large number of situations. When we have a single input attribute, x, and we want to use linear regression, this is called simple linear regression. Simple linear regression, we want to model our data as follows. Y equals b0 plus b1 multiply x. We know and b0 and b1 are coefficients that we need to estimate that move the line around. Simple regression is great because rather than having to search for values by trial and error or calculate them analytically using more advanced linear algebra, we can estimate them directly from our data. Less regression. Linear regression using ordinary least squares approximation. Based on Gauss-Markov theorem, we can start off by estimating the value for b1s. Using the below formula is calculate the slope. To calculate the slope, you can use the formula that involves summation. Intercept values calculated and stored it as bb0, b1 variables. If we had multiple input attributes, e.g. x1, x2, x3, etc., this would be called multiple linear regression. The procedure for linear regression is different and simpler than that for multiple linear regression. Consider the following example. Y equals 2x plus 3. To calculate the mean of x and y, use the mean formula. Then, in the third column, calculate the 11 values by subtracting the mean of x. Similarly, in the fourth column, subtract the mean of y from the e-values. In the fifth column, multiply the values in the third and fourth columns. In the sixth column, multiply the values in the third column by 2. To calculate the slope of a linear regression, you can use the formula that involves summation. After calculating the intercept values, store them as b0 and b1 variables. Substitute with the b1 formula, we can get the result of b1 equals 2. Like b0 equals 3. Again, substitute, we can draw a regression line. Below this, some other explain using your programming language. How to calculate x vector 1, 2, 3, 4, 5. Y vector 1, 3, 3, 2, 5. b1. Before point scatter values are there after calculating slope and intercept values we got the straight line.